This is Learning Assessment Problem 9-7. The problem-solving strategy here is that of maximum average power transfer. In the problem, we are asked to determine the value of the load impedance Z sub L, which will maximize the average power transferred to that load, and also determine the maximum power which can be transferred to that load. We'll label some quantities here for our convenience. We have a voltage across the inductor V sub L, and we'll label the terminals of the load impedance A and B. In order to do the maximum power transfer calculation, we'll want to determine the Thevenin impedance of the circuit and use the concept that Z sub L for maximum power transfer will be the complex conjugate of the Thevenin impedance of this circuit. So our first step will be to find the Thevenin impedance, the TH. The equivalent circuit that we'll work with is obtained by removing the load impedance at the terminals A and B and setting the sources to 0. In this case, both sources are voltage sources, so they will become short circuits. So this is the equivalent circuit. We'll proceed first by calculating the impedance Z sub P, that parallel impedance. Z sub P will equal J2 times 2 divided by 2 plus J2, and that is equal to 1 plus J1 ohms. Then Z Thevenin will equal this parallel impedance Z sub P minus J2 ohms for the capacitor, which is equal to 1 plus J1 minus J2, and that is equal to 1 minus J1, or square root of 2 at an angle of minus 45 degrees ohms. From this expression, we can say that the ZL maximum power will be the complex conjugate of Z Thevenin, which is equal to 1 plus J1. And from this we can say that the RL, the real part of that for maximum power transfer, is equal to 1 ohm. To determine the maximum power which can be transferred to the load under the matching condition, we'll have the expression P sub L maximum power is equal to the magnitude of the open circuit voltage phasor squared divided by 8 times the Thevenin resistance component of that Thevenin impedance. We'll consider a loop current IOC in this left-hand path. We'll calculate IOC as the sum of the voltages in that loop divided by the impedance in the loop, or the phasor current IOC is equal to 12.728 at an angle of minus 45 degrees amperes. Now we can calculate the voltage across the inductor V sub L is equal to J2 ohms times that IOC current, which is 12.728 at an angle of minus 45 degrees, and that is equal to 18 plus J18 volts for the voltage across the inductor. Now we can determine the open circuit voltage as the sum of V sub L minus the voltage source 12 at an angle of 0 degrees volts, and this is equal to 6 plus J18 volts, and VOC is equal to 18.974 at an angle of 71.57 degrees volts. Now we're ready to calculate that maximum power which can be delivered to this matched load. That's equal to the square of the magnitude of this open circuit voltage divided by 8 times the Thevenin resistance component. And our maximum power which can be delivered to this matched load is equal to 45 watts. And that ZL load for maximum power transfer is equal to 1 plus J1 ohms.